A very good morning to all of you. Today we will be discussing about excitement in physics. Physics is one of the most fundamental of all sciences. It forms the basis of understanding of various naturally occurring phenomena. It is used to understand chemical reactions, for example, molecular motions in biological systems, aspects like photosynthesis and so on. This understanding leads to development of devices and systems for various applications. And once you understand the fundamental laws, it will then help us to predict behavior of various systems. Physics involves the study of nature. Have you ever wondered why the sky is blue? How are rainbows formed? If I throw an object like a stone, why does that fall to the ground? We are receiving light from the sun. Our life on this earth depends on sunlight. How does the sun produce this light? How do stars produce light? By making measurements on this light, can I conclude anything about the sun and the star, the kind of elements present in those objects? We have seen comets appearing on the sky, we have passed through eclipses. Can I predict when will the next eclipse appear? When will the next solar eclipse appear? When will the next lunar eclipse appear? When will the next comet appear on the sky? Why are some substances good conductors of electricity while others are poor conductors? For example, metals like copper are very good conductors, but other objects like wood are very poor conductors. Why is it so? So, these kinds of questions are answered by understanding the laws of physics. So, physics deals with discovery of general universal laws governing all natural phenomena through experimentation. So, you devise certain experiments and use those experiments to make measurements, and from those measurements try to develop some universal laws. So, for example, I drop a heavy object from a certain height, I can measure the time it takes to fall to the ground. I can drop objects of different weights and measure the time it takes to fall to the ground. So, these observations will help me to understand what is the time taken by an object to fall to the ground, does it depend on the mass of the object, does it depend on the shape of the object, etc., etc. So, these experimental observations help us to develop laws, universal laws, which will be useful in understanding them and also predicting new things. It is also interesting to know that the same laws apply both on the earth as well as in the most distant galaxies. It is the same set of laws that apply both here and elsewhere. So, the laws governing falling stones on the earth are the same as the laws governing motion of planets around the earth, motion of galaxies. So, all the laws are exactly the same. So, also laws governing electricity and magnetism, for example, are universal and they apply to all electromagnetic phenomena occurring at all places in the universe. The light signals we receive from distant objects have similar behavior as the lights that we are generating on the earth. The radio waves that we receive from pulsars outside from the universe have the same properties as the radio waves on the earth. So, these laws are very universal and they encompass a huge set of phenomena, and it is these development of these laws that forms the study of physics. Now, physics is also involved in the study of phenomena at very diverse scales, as huge a scale as the scale of the universe to the scales of subatomic particles. So, you want to develop laws that will describe phenomena occurring at very different scales of length, time, etc. And it is also important to know that it is possible to derive properties of bigger and more complex systems from the properties and interactions among its constituent parts. So, knowing the properties of molecules and atoms, I should be able to derive certain properties of the solids and liquids that are formed by these atoms and molecules, and physics explains what are the properties of the solid matter, how are they related to the properties of the atomic particles, and so on and so forth. So, you can derive properties of much more complex objects starting from properties of its constituent parts and the way they interact. Physics forms the foundation of all engineering and technology which have huge impact on our lives. The most common example today is the internet. Children growing up at this general IQ now are taking internet for granted. So, there is a lot of physics, there is a lot of engineering, there is a lot of technology that has gone into development of the internet. Mobile phones, all of us are now carrying mobile phones, and we can communicate between any person anywhere on the earth by using our mobile phones at any time. We are all so much used to computers. Computers are used for all kinds of applications, right from booking tickets to calculations to predictions, etc., etc. And computers are forming a very, very important part of our research and also everyday aspects. Human beings requires energy. So, we are tapping solar energy, nuclear energy, wind energy, etc., and all this requires a lot of understanding of basic physics involved in these processes, understanding those physics and then developing techniques, materials, so that we can use these to generate energy for ourselves. Space travel has advanced significantly. Man has been put on the moon quite some time ago. So, there are a lot of efforts now to approach Mars, and again all this requires a basic understanding of physics, application of engineering and technology. Apart from these applications, apart from these reasons, there is another very important reason to study physics. Physics is like an adventure into an unknown territory. So, you are investigating aspects of phenomena which is completely unknown. So, it is very challenging and intellectually very stimulating. Because it is intellectually stimulating, it is very absorbing and satisfying and very richly rewarding. You may spend years together trying to understand certain phenomena, trying to experiment, set up experiments, and after years of hard work, you suddenly understand certain aspects, certain concepts, and that gives you a eureka moment which can really uplift you into understanding into a very, very different situation. So, the study of physics has been going on for a long time, and the current understanding is based on foundations laid down by great scientists like Galileo Galilei, Isaac Newton, James Clerk Maxwell, Albert Einstein, Max Planck, and many other scientists who have contributed to the present understanding of physics itself. So, physics builds on finding laws that explain experimental observations. So, you do experiments and you try to develop laws that will describe the experiment that you have carried out. Then those laws have to be tested by using more advanced experiments. I need to do more experiments and test those laws further. Not only that, these laws that have been developed also predict new phenomena which then needs to be verified. So, we do experiments, based on those experimental observations we develop a theory or a law, then that law is used to explain all the experimental observations. That law is tested using more advanced experiments. That law then predicts certain features, new phenomena which can then be verified by experimentation. It is important to remember that just one experiment can disprove a theory. You may have a theory and just one experiment can show that that theory is incomplete or inconsistent or needs modification. And it is impossible to prove a theory is perfectly right, because you never know when a new experiment can be performed that will disprove your theory. So, there are a lot of scientists working to continuously verify theories to see there are any features, and there is a lot of phenomena still to be understood in nature which is requiring development of new laws, modification of existing laws, and sometimes revolutionary ideas. An example of this is to understand what is light. Way back in the 17th century, scientists like Descartes and Newton proposed what is called as the corpuscular theory of light, particle theory of light. That means, they said that light consists of particles. So, when light comes out from a source such as a bulb, there are particles which are coming out, and using this picture they could explain the propagation of light along a straight line, because we all know light propagates along a straight line. So, they could explain this. The fact that light can propagate through vacuum can also be explained. The fact that we are receiving light from the sun and other stars, in between which there is hardly anything, just vacuum and free space, can be explained using this picture, and of course, it was used to explain reflection, refraction, and many other phenomena. So, that was one of the original theories of light, that what is light was explained using this particle picture of light. Then in the 18th and 19th centuries, scientists carried out some experiments. Thomas Young, Augustin Fresnel, these people carried out some experiments on interference and diffraction. You may have heard of beats of sound. So, if you have two sound waves whose frequencies are very close to each other, then when you hear them simultaneously, you will hear waxing and waning of sound. The intensity of sound increases and decreases and increases and decreases, and that is because of interference of the two sound waves. So, it is well known that waves have property of interference and diffraction. So, diffraction means if you pass a wave through a certain restricted aperture, the waves comes out in a diverging pattern. So, people conducted experiments to show that light has the phenomenon of interference, also diffracts. So, they proposed that light is a form of wave, and this wave theory could explain all the observed phenomena at that time. So, this wave theory replaced the corpuscular theory, because corpuscular theory could not explain certain features which the wave theory could explain. Then came Maxwell in the 19th century, who developed equations to show that light wave is actually an electromagnetic wave, a wave that consists of electric and magnetic fields. So, the electric field which is changing with time generates a magnetic field which is changing with time. The changing magnetic field produces a changing electric field, and these two couple to each other and propagate in the form of a wave. So, this phenomenon can then explain the fact that light waves can travel through vacuum, because these are simply electric and magnetic fields propagating through space. So, it was understood and verified experimentally that light is form of an electromagnetic wave, and then of course, you have electromagnetic waves over the entire spectrum, radio waves, visible waves, ultraviolet, infrared, X-rays, gamma rays, and so on. So, you have a wide spectrum of electromagnetic fields, electromagnetic waves, and light is only a part of that electromagnetic spectrum. So, that was well established at that time, and in the early part of 20th century some experiments could not be explained on the basis of the electromagnetic theory of light. So, a new development had to take place, and that is the quantum theory of light. So, Einstein explained the photoelectric effect, and soon after that there was a lot of excitement in physics in which people developed the entire field of quantum mechanics to explain many features including light. So, what comes out of this picture is that light is neither a wave nor a particle, and it behaves sometimes like a wave, sometimes like a particle. It is neither the wave nor a particle. And with this picture of light, we developed the concept of photons. So, we assume that light can be absorbed and emitted in packets of energy which are called photons. And this picture, which is the quantum theory of light, can explain all observed phenomena as of now. So, this picture of light, which is now currently taken as the correct picture of light, can explain all observed phenomena, and unless some other experiment in the future is shown to not to follow this principle, until that time we will assume that the quantum picture is the right picture. Now, when you develop laws to explain certain features, as I said before, that picture also predicts new phenomena. So, the current theory of light, which is based on quantum mechanics, predicts certain new forms of light with strange and counterintuitive properties. That means properties which cannot be understood in a normal sense, they are against intuition. So, once the prediction takes place, people then conduct experiments and have verified that these counterintuitive properties are actually real properties. That means, the predictions of the quantum theory of light are actually verified experimentally, and that actually further emphasizes that the quantum theory is a correct picture. This picture of light now, the quantum theory of light, is leading to a new field of science, engineering and technology, which is called quantum information science and technology. This field is now being developed to achieve secure communication, the field of cryptography, where you encrypt messages and send across the internet, for example, high speed computation, extremely sensitive sensing and so on. So, there is a lot of activity in this branch of engineering and science, and physicists, computer scientists, electrical engineers, material scientists, all people are involved, chemists, everybody is involved in developing this field of quantum optics. Now, we must understand that all physical laws have a range of validity within which they operate. So, the laws which are used to describe motion of say planets or the motion of a stone thrown is essentially part of classical mechanics, and there is a certain mathematical structure which is used to explain this. Now, that mathematical structure is not valid at microscopic scales. So, at microscopic scales, when I have to describe how an electron trajectory moves, how an atom moves, etc., I have to use the field of quantum mechanics. So, I must be aware of the range of validity of the laws and models which I am using. Similarly, at very high speeds of particles, I must use the principle of relativity, which was developed by Einstein. And so, depending on the problem at hand, I must be able to use models which are valid for that range of operation. Now, so when I have a physical system to describe or to understand, many times I will use highly simplified models. So, let me take an example of to understand how the motion, what is the trajectory of a cricket ball which is thrown in air. Now, if I look at the problem very correctly, I know that the ball is not exactly spherical, it has some bit of maybe ovality in it. The surface of the ball is not perfectly smooth, there are stitches on the ball is moving through air which has resistance, there is wind, and if I need to take a model in which I take into account all these parameters, the problem becomes very complicated. Now, in many aspects, in many times I need primarily the trajectory of the particles. So, we can now concentrate to develop a simplified model. I can concentrate on the most important and judiciously chosen parts of the problem. So, in this example, I can describe the ball as a particle. I can neglect air resistance, wind movement. I can assume that the acceleration due to gravity does not depend on height and solve the problem. So, this is a highly simplified picture of the given problem, and this simplified picture will give me a trajectory which in most situations will work reasonably well. Now, I am sure there are situations where this model may not work, and for that I must modify the model to take into account other effects, but we must remember whenever I apply a model to a problem, I must remember the range of validity of that model and then simplify the model in terms of judiciously chosen approximations and solve the problem. As experimental science getting better and better, technology is advancing, and this advancement in engineering and technology is actually allowing us to perform more and more intricate experiments. Experiments which could not be performed maybe 20 years ago or 50 years ago can now be performed. A very interesting example is the detection of gravitational waves. Gravitational waves were predicted by Einstein about 100 years ago through his general relativity theory, and one had to wait for 100 years for the development of sensors and technology which could detect the existence of these gravitational waves. Incidentally, this detector works on the same principle as the experiment used by Michelson and Morley to check the existence of ether. So, it is an experiment which then can be is performed today and has detected gravitational waves. So, it required a lot of time to develop technology to achieve the required sensitivities, and further improvement in development of the detector technology is in progress to improve the sensitivities, to detect even more weaker gravitational waves, and this is based on what is called as a LIGO, laser interferometer gravitational wave observatory. And it is very nice to know that there is a LIGO plant in India somewhere, and that will give an opportunity for scientists, technologists and engineers in India to work with the international teams in this extremely important and exciting adventure of detection of gravitational waves. Physics find many important applications, and I will just briefly discuss one or two applications which have had very strong impact on our lives. So, let me come back to internet and mobile telephony. We all take for granted the existence of an internet, the existence of a connectivity, and we all take for granted the fact that I should be able to talk to anybody anywhere on this earth at any given time. I should be able to download information, I should be able to download movies, etc., just by clicking the mouse of a computer or the tap on a screen. I should be able to chat with friends, upload photographs, and also what is developing is Internet of Things, where various equipments and components are connected through the internet. Now, all this has been made possible because of the development of using light for communication, and there is a lot of physics behind this technology that has been developed. For example, it involved understanding of the properties of electromagnetic waves, it involved understanding properties of materials, not only understanding, engineering, fabricating, designing, measuring, characterizing, etc. All this involves a lot of physics, engineering and technology, development of lasers as a source, lasers detectors, very sensitive detectors development, and of course, integrating all these components into a technology which can be used for communication. So, today this optical fiber network has millions of kilometers, all made of glass, carrying information. So, whenever we telephone or we send information through an internet, all this data and information and voice is going through millions of kilometers of optical fiber. This is forming a complete network around the globe. And as increasing demand for communication takes place, there is further and further research in understanding, in developing new methods for communication and to increase the speed of communication. And people have already demonstrated capacities of terabits per second, that is 10 raised to the power 12 bits per second communication systems. So, what is the physics behind all this application? How can I send a light wave from one place to another place distance by about 10,000 kilometers? How is light propagating through this? How is information being carried? So, it is based on the simple phenomenon of total reflection. So, you have, if you take a medium, a denser medium and a rarer medium, when a light wave impinges on this interface from the denser medium, there is a small amount of reflection takes place and there is a refracted ray. And we know that the angle of refraction here, this angle is more than the angle of incidence, because it is going from a denser medium to a rarer medium. Now, as I increase my angle of incidence, the refracted ray bends and more until I reach a critical angle at which the refracted ray grazes the surface. This angle is called the critical angle, and if your angle of incidence is beyond this angle theta c, then there is total internal reflection. There is no transmitted wave, all the light incident on the interface is reflected, and that is 100% reflection. Please note that this is different from reflection from a metal, because a metal reflection is never 100%, there is always some absorption, a very small amount of absorption, but a finite absorption. This is 100% reflection. So, using this phenomenon, there are optical fibers which are cylindrical structures. These are hair thin fibers which have a core and a cladding. There are two materials, slightly different refractive indices. The inside core has a slightly higher index than the outside cladding, and this leads to the phenomenon of total reflection at the interface. And if you launch light from one end, light can guide through this fiber for thousands of kilometers. This is a photograph of an optical fiber which is 25 kilometers long, carrying light from a green laser. Now, you can see the light coming out from the fiber, and that is based on the phenomenon of Rayleigh scattering. The same mechanism that leads to the blue sky is responsible for you are able to see this fiber from the sides, because if it is total internal reflection, I should not be able to see the fiber from the side, and that is simply the Rayleigh scattering that is taking place. So, there have been, that was one application. There are many other applications which have come about. We all take for granted the GPS systems, global positioning systems, and we must remember that the GPS system uses relativity theory for its accuracy. You can use electromagnetic levitation, electromagnetic induction, and people have developed what are called as maglev trains, magnetic levitation trains, which are super fast. And it is interesting to learn that Indian Railways is exploring such trains to run in India at speeds of 500 kilometers per hour. Space exploration is a very important area, and India has done extremely well in this branch. Space exploration requires a lot of understanding of the basic physics, of the technology and engineering. In fact, for example, if you have to land any object on a planet like Mars, we need to be able to calculate very precisely the trajectory and the mechanics of the motion of these objects. With increasing research in material science, with properties which are being modified, people are developing more and more miniaturized electronic devices. And with miniaturized devices and technology, we are having new games like all of you must be familiar with Pokemon Go, which uses the GPS, the global positioning system, to locate and capture virtual creatures. With all this understanding, technology, engineering, the future games is very good, and I am sure as time progresses new and newer types of games will be coming up on your mobiles. Now, we use mathematics to describe various natural phenomena. So, when you do experiments and look at the observations, you try to condense all the experimental observations into mathematical laws which take the form of mathematical equations. So, mathematics is a very important component of physics. So, these mathematical equations not only explain the observed phenomena, but also predict new phenomena. So, you form an set of equations which describes what you are observing, but those same set of equations will predict, as we discussed a little while ago, new phenomena. Now, it is not always necessary that this new phenomena can be verified immediately, because it may need development of new technologies and new understanding before some of these can be tested experimentally. So, I just want to give one example here. We are all familiar with the mirage on a desert. So, on a hot day, the air near the ground is hotter than above. So, the refractive index of air changes with height. So, if you have a tree here, palm tree, the light ray coming from the palm tree does not travel along straight lines, but curves itself. Because the refractive index of the medium is not constant, such a medium is called an inhomogeneous medium. Refractive index changes with height, and that leads to a curvature of the light ray. So, light rays curve along this path, and if you are an observer standing here, your eye will project this light ray into this direction and will see the leaves of this palm tree below the ground. So, it will appear to you that there is a reflection from this interface here which is on the road. You also get light rays directly from the palm leaves that also shows you the object and its image. So, it gives you a feeling of reflection, feeling of presence of water, and that is a very interesting observation. If you travel on a hot day outside on the road, you will be able to see this mirage very clearly. So, the question arises, can I design media in which we can control the path of light and other forms of waves? Can I have invisibility cloaking? So, can I cover an object with such a medium so that light goes around the object and makes the object invisible? So, for example, if I am standing here, can I cover myself with an object such that light ray from behind comes like this straight, bends around me and goes like this. So, the light ray which is starting from behind me comes straight, goes around me and goes straight. So, that for an observer sitting in front of me, he will not be able to see me, but he will see the blackboard behind me. So, this is cloaking, and I can be made invisible by this mechanism, and you must have all read Harry Potter stories where such cloaking has been used. Now, in this context, I want to just mention some interesting developments. For example, if you take a medium such as glass and shine light from air, there is a reflection and there is a refraction, and we all know that the refracted ray and the incident ray are on opposite sides of the normal. So, if the incident ray comes from here, which is on the left of the normal, the refracted ray is on the right of the normal. Now, people have analyzed and found that it is possible to have media in which the refracted ray exists on the same side of the normal as the incident ray. So, here is the incident ray and the transmitted ray goes like this, and this medium is called a medium of negative refractive index. So, how do I generate this media? I can engineer materials, I can produce my artificial materials which are not found normally in nature and get what are called as metamaterials. These are materials which have properties which are normally not found in nature. So, how do I fabricate these? I modify the internal structure of a medium and to obtain such interesting properties, and these structuring, which means that I must have modifications of the structure of the material itself at scales smaller than the wavelength, of the radiation, and I can actually have these media metamaterials which can have very interesting properties. And the recently developed technology of nanotechnology is used for fabricating these devices, and many of this research work is going on to have invisibility cloaking not only at the optical frequencies, at the radio wave frequencies, also perhaps at acoustic frequencies. So, you can actually use the same kind of principles to have interaction of this media with all kinds of waves. So, these metamaterials can be used for invisibility cloaking, can be used to generate super lenses with extremely high resolution, much higher resolution than possible normally. It can help us to develop extremely small antennas for sleek and slim mobiles. It can be used in satellite communication and many more applications. It is possible to perhaps think of dynamically changing properties of these metamaterials, think of acoustic metamaterials and so on. So, it actually broadens our perspective and gives us new ideas to develop new kinds of materials with microstructuring, which can help us to understand, design, fabricate and use in some of these materials. Now, all this is exciting physics, but apart from this, studying physics also gives us analytical thinking and problem solving skills. So, in physics we tend to reduce a very complex problem into more basic components and analyze the problem in that fashion, and that skill you develop as you study physics, as you apply physics, as you solve problems in physics. And these skills are not only useful in physics, in sciences, but also throughout your entire life, because these are basic skills that you develop and help you to have a good future. Not only in sciences, studying physics is also used in disciplines such as economics, finance, etc. Now, apart from physics, there are other sciences like chemistry and biology, which I was mentioning in the beginning, and there is always very interesting developments to combine these fields of sciences, and today there is a very interesting field of biology mixing with chemistry and physics, which is called biomimetics. It is an interdisciplinary field combining physics, chemistry and biology, and this is based on the fact that living organisms have evolved over millions of years of natural selection. So, they have characteristics which have been evolved over a long time, and the question is, first of all, what are those properties, what are those characteristics, can we develop materials and systems that mimic these biological systems, and this will help us to design and develop new technologies. There are many examples. The most interesting example is Velcro tape, which all of you are aware of, where you stick two surfaces together through hooks and then separate them out. These have actually developed by looking at some plants which have hooks. There are inspirations from raptors and owls to develop wings that can change shape to reduce drag. People are looking at termite mounds which regulate temperatures, so architects are interested to understand the behavior of these. There are medical scientists looking at developing new hypodermic needles which are like mosquito proboscis, which can reduce the effect on our nerves and reduce the pain. And of course, we need to understand magnetic navigation in animals, birds and insects, how they use magnetic fields to navigate and how they use polarization of light to navigate and so on and so forth. So, there is in nature a lot of other living organisms which use many other techniques for their lives, and is it possible to understand them, to investigate, to use those same principles in designing our own systems. For example, have you ever wondered about the colors of a peacock feather and some kind of butterflies called iridescent butterflies? The color of a peacock feather is very different from the color of a flower like rose. If you look at a rose no matter what direction you see the rows, it will have the same color, but a butterfly or a peacock feather has different colors depending on the angle of viewing. Actually these have structures at the nanometer scale. So here are two examples. On the right is a peacock feather here, the eye of the peacock feather here, and you can see the colors. If you rotate the peacock feather, you will be able to see that the colors change, and that is the color of a beetle here. You can see shining colors. These colors are produced primarily by the microstructured surfaces on these insects and other objects like feathers. And so our objective in physics would be to understand the origin of these colors, to fabricate such structures, and to design things which may have applications for us beyond what we have today. So some of the applications of such interesting observations are color tunable textiles whose color can be tuned, anti-counterfeiting technology, new kinds of thermal sensors, and so on. So there is endless applications we can think of by taking examples from nature and using them in our everyday life science and technology. So that was a discussion of our physics, excitement in physics, and we will see that you have in class 11 you will have to study the following subjects: Newton's laws of motion, energy motion of rigid bodies, gravitation. You will be studying properties of matter, mechanical and thermal properties. You will be studying thermodynamics, kinetic theory of gases, and waves and oscillations. All these will form a subject of class 11. Class 12, you will be studying the very important subject of electromagnetism. These are laws describing electric and magnetic fields, electromagnetic waves which we have discussed before, applications of electromagnetic waves, and optics which forms a part of electromagnetic waves, electromagnetic spectrum. You will understand optics and its applications. You will get partly introduced to the field of quantum mechanics through the subject of matter waves and wave nature of particles. As I mentioned to you, light is neither a wave nor a particle, and this concept is extended to other objects like electrons and protons and neutrons. So you will be trying to study the basics of that, and I am sure as you progress later in your careers you will get into more and more details of these basic structures. There are subjects of atoms and nuclei in your course, electronic devices which form a very important part of today's systems. All our mobiles, computers, and many more devices use miniaturized electronic components, and there is always a demand to decrease the size of these devices and at the same time increase the capabilities of these devices. And some bit of communication systems which you will be studying. One of the applications, as we have seen, is the communication through the internet, which is an extremely important aspect of our life today. The future of physics. We may think that a lot of studies have been done in physics. It has been developed over centuries now, but let me tell you, there is still a huge field of exploration in front of all of you. At different stages in the development of physics, people thought that everything that had to be developed had been developed. In fact, that was the picture at the end of the 19th century. But then things changed with the development of relativity theory and quantum mechanics, which has helped us to completely revolutionize our thoughts. In fact, physics has influenced strongly the philosophy and our objective, the view of our objective world. So there is still a lot of exploration field for all of you to get into, and I am sure some of you will venture into this unexplored territory and discover new phenomena and create new paths for others to follow. I wish you grand success in all your studies. Do well in whatever career you choose for yourself. In class 11 and 12 you will study physics, chemistry, biology and other subjects. Enjoy learning. The skills that you develop will always be very helpful to all of you in your future careers and lives. So work hard and enjoy the subject that you are learning. I would like to end the lecture by a quote by our very famous scientist Sir C.V. Raman, who said, "Intellectual beauty is indeed the highest kind of beauty." Science, in other words, is a fusion of man's aesthetic and intellectual functions devoted to the representation of nature. It is therefore the highest form of creative art. So, physics, as we have discussed today in a brief lecture, is one of the most fundamentals of all sciences. It is exciting to study physics. It helps us to develop other skills in life. It has helped development of engineering and technology. It forms the basis of all this technology and engineering, and there is a broad future which lies ahead to understand more and more of this nature as a reality, and also develop understanding this physics to develop new kinds of devices, new kinds of applications, new kinds of materials, etc., and help us in developing further the understanding of the basics and also development of engineering and technology. Thank you very much.